Good afternoon, everyone. Welcome to day 5 of our E&ICT FDP on optimization technique for in application. So, like every day, we have two sessions today. In the first session, we'll see some of the multi-criteria decision-making methods. In the second session, we'll discuss about harmonic search algorithm and firefly algorithm by Professor Manjuvala BC Madam. And in line with these MCDM methods, we have also two sessions related to the MCDM methods. One session is I'll cover some of the MCDM method, and other methods will be covered by Dr. Akhtar Khan on 18th March, first session, that is on Monday. So I'll discuss about, I think, I'll discuss about 7 MCDM methods, and he will discuss about another 2 MCDM methods with their possible implementation. So the name suggests multi-criteria. So multi-criteria means you are given with a set of criteria. Like in day-to-day life, whenever we go to purchase a particular item, also we are looking into various type of criteria. For example, I can say quality is one of the criteria. Quality can be considered as one of the criteria. Cost can be considered as one of the criteria. Warranty and guarantee can be considered as another criteria. Warranty and guarantee. Okay, guarantee can be considered as another criteria. Right. So you are having a set of criteria. So by looking into the set of criteria, we have to finally take a decision. For example, there is a product P1, there is another product P2. So as a customer, you can look into both product P1's features and P2's features, and finally you have to decide whether you have to purchase P1 or P2. So that can be solved if your requirement is clear. So by looking into your requirement, you can see whether your requirement is matching with P1 or it is matching with P2. So based on that, you can take a decision that whether to go for P1 or P2. Okay. So finally, our objective, decision making. Decision making means by looking into multiple criteria, we have to decide whether to go for product P1 or P2. So in order to do this one, there are a couple of methods. Like many scientific engineering problems, you have to take a decision by looking into set of criteria. So in those cases, what you can do, you can apply the multi-criteria decision-making problem. So these are the methods we are going to discuss after the introduction. We are going to discuss about one very simplest method, that is called as weighted sum method. There is another method that is called as weighted product method. These two methods are quite old, and although it is quite old, but you can see if you look into application perspective, many people are all still using WSM or WPM method. Apart from this method, we have another method called Promethi. Promethi stands for Preference Ranking Organization Method for Enrichment of Evaluation. There is another method that is called as Beaker. So you can see the full form of Beaker is a little bit odd, right? because it is a Serbian term. This is written in Serbian term. It is not written in English, so it is difficult to pronounce and difficult to read. Then we'll see Mura, that is multi-objective optimization using ratio analysis. Then TOPSIS, that is technique for order preference by similarity to ideal solution. And one of the very popular MCDM method, that is called as analytic hierarchy process. And the last one, that is GTMA, that is graph theory matrix approach. So out of all these 8 methods, I'll discuss about 6 methods, and we'll discuss about Mura and AHB on 18th March. That will be covered by one of our colleague from IIIT Kurnool. His name is Professor Akhtar Khan. He will cover about these two with its implementation. Okay, so let us start. So I told you in multi-criteria decision making method, you are given with a set of criteria, right? Based upon the criteria, you have to finally take a decision. So MCDM problem is divided into 2 pipes. One is called as multi-objective decision making. Another is called as multi-attribute decision making. So the problem is broadly divided into 2 parts. One is multi-objective. Another one is multi-attribute. Multi-objective means, for example, if you want to move from a city X to another city, let's say Y, city X to city Y. So if you go by air, right? If you go by air, the cost is more and time is less, right? But if you go by rail connection or by train, the cost is less, time is more. So you can create a multi-objective function. So you can say, for example, I can say f of x is equal to lambda 1 into, let's say, another function f1x plus 1 minus lambda 1 into f2 of x. So here I consider f1x as cost, I consider f2x as time. Okay, so you have 2 criteria, you have 2 objectives. One is you have to minimize the cost, on the other hand you have to minimize the time, and you want to achieve both things. Your objective is not a single objective, your objective is a multiple objective. So but finally you will get f of x, right, which is taking the linear combination of f1x and f2x. So in that case, what you are applying, you are doing multi-objective decision making, MODM. But multi-attribute decision making case, again, time may be considered as an attribute, cost is considered an attribute. But together, like in the previous case, you are considering various objectives into concern. Here, these are not objectives, these are considered as an attribute, right? So our objective in the MODM method is to apply to a design problem. But when you go for MADM problem, it is focusing on a selection problem. So this is the major difference you can find. Selection means if you have more than one alternatives, right? For example, like I mentioned, product 1, product 2, product 3, and product 4. So finally, you have to choose one of the product. You can choose product 1, or you can go for P2, P3, P4, anything. Okay. So let's say you have applied these MLDM techniques and you found that P2 is the well suitable for as per your requirement. But we are not doing that in multi-objective. Multi-objective case, you are given with more than one objective and you want to balance the objective. Here we are not balancing the objective. Here we are making a selection. That's why it is suitable for the problem which is design in nature. It is related to a problem where selection is the major concern. And if you go for MDM problem, you can find infinite number of solutions, but MADM case you are going to get finite solutions. If you have 4 alternatives or 4 products, then you will get 4 selections only. Somebody can say that I'll prepare it first. Let's say I'm preparing it second, I'm preparing it third, and I'm preparing it in fourth, right? So you will get a finite number of solutions. So normally, whenever there is a continuous value, we'll go for MODM. When we have a discrete value, we are going for MIDM. So you can look into whether you need your problem is a MODM problem or it is a MIDM problem, that you have to identify. So in the upcoming lectures also, we have a single variable optimization method and a multi-variable optimization method that will be covered in the next week. So in these methods, you will see more or less the MODM. But in today's class and Monday class, you will see whatever we are discussing methods, they are MIDM methods. Okay. Now, if you go for a MIDM problem has 4 main components. First component is called as alternatives. Alternatives are nothing but solutions. Each and every alternative is a solution. It may be a good solution, it may be a poor solution, but it is a solution. And you have to see that number of alternatives should be finite. Okay. And these alternatives are characterized by attributes. Like if I say, tell me the attributes of car, and somebody can say color, somebody can say horsepower, somebody can say miles per gallon. So different attributes we have, right? So every alternative has set of attributes which characterize that particular alternatives. So these two are very main important. So if we have multiple attributes, each attribute is given as a weight. Because for example, cost is, so you are giving more weight to cost. If you think that no, color is more important, then you can give more weight to color. So it is a relative importance of an attribute. And note that finally you have to make sum of all weight is equal to 1. It may not be initially 1. If you sum all the weights, it may not be 1. But when you apply MCDM techniques, we normalize all the weights to 1. Another component is that measure of performance of each alternative with respect to the attribute. For example, assume that if you are taking, let's say, in a particular car, let's say you are there is a there is a car A, there is another car, or you can say some features of the car. Features of car. So it is A, B, C, and D. Okay, and assume that you want to buy a particular car by looking into the feature A, B, C, and D. And when you enter to the showroom person is showing you varieties of car, which I represent as 1, 2, 3, 4, 5. Okay. So what you can do, you can put weight to each and every feature, right? For example, I can put A is more important for me. So I can put a feature, let's say 6. So next important is my C. So I can put 3. Next important is B. Next important is 1. Okay. So based on your importance, you can put weight, where higher value indicates more importance, lower value indicates less importance. So what are the alternatives we have here? Our alternatives are in this example 1, 2, 3, 4, 5. What are the attributes you are looking for? A, B, C, and D. What is the weight values? 6, 2, 3, 1. So for each car, you will find a value for A, a value for B, a value for C, and a value for D. Similarly, for the second car also, you will get ABCD. Third car also, you will get ABCD. fourth car also will get, fifth car also you will get. These values are called measure of performance of each alternative with respect to the attribute. So these are the of four different components of MADM problem. But although it is a MADM problem, but if you go to literature, people call this is a MCDM problem. Out of, as I mentioned, MCDM is of two types. One is multi-objective decision making, another is multi-attribute decision making. But MADM is very popular in comparison to MODM. That's why many people call this problem directly as MCDM problem. Okay. So let us see one by one method. So in each and every method, you are given with these four components. What are the components? First component is alternatives, that is A, B, C, D. Attributes, sorry, alternative is 1, 2, 3, 4, 5. Attribute is A, B, C, D. Weight is 6, 2, 3, 1. And you are given with the performance measure with respect to each alternative with respect to attribute. These are given to you. So one by one, we'll apply the MCDM methods and we'll solve using that particular method. Finally, that method will help us to tell which alternative is better. So two things we are doing here. First thing, you are deciding which alternative is better. Another thing also you are doing, you are ranking alternatives. So if 5 alternatives are given, you can ask rank based on my requirement. So it will rank also based on your requirement. So these are the methods that are applied to MADM, but the list is very small here. If you go to literature, you can find many more methods. But these methods are said to be some of the basic methods of MCDM problem. Okay, let us start with the first method, that is called as weighted sum method. So all of us know what is sum. Sum is nothing but if I do 1 plus 2 plus 3 plus 4 plus 5, we call that is a sum. Weighted sum means I'll put a factor which is going to be multiplied with 1. Let's say another factor multiplied with 2, another factor multiplied with 3, another factor is multiplied with 4, another factor is multiplied with 5. So that can be treated as weighted sum method. Okay. You multiply a particular weight with 1, 2, 3, 4, 5 respectively. So whatever sum you are going to get, that is called the weighted sum method. So let us try to understand a problem, numeric problem, which we are going to solve using weighted sum method. So this particular problem is a problem related to mechanical engineering. It is not a problem related to computer science. So what is that problem? Select the optimum material for a cryogenic storage tank. So you know cryogenic has more importance in space vehicles. So you have to choose an optimum material for a cryogenic storage tank for transportation of liquid nitrogen for the data tabulated below. So if this problem is not understood to you, just imagine that there are 4 different attributes or criterias, okay, and there are 7 different alternatives. These are the 7 different alternatives, and these are 4 different criteria or attribute, you can say. What are the criteria to select this optimum material for the cryogenic storage tank? The attributes are given as TI, which stands for toughness index, YS stands for yield strength, D stands for density, T stands for thermal. Okay. If you are belongs to non-mechanical engineering branch, you can consider this is your attribute A, this is attribute B, this is attribute C, and this is attribute D. That's all. You have 7 different material, and each material is characterized by 4 different attributes. Okay, or criteria. So each and every criteria is given with a weight value. These weight values are generated randomly. So the weight value given for toughness index is 6, for yield strength it is 2, for density it is 3, for thermal it is 1. So if you sum these values, the value is not equal to 1. But you have to make it 1 before applying any type of method, right? So what it indicates? It indicates that toughness index has more importance in comparison to all other attributes. Similarly, T is more importance than YS and T, and YS has more importance than T. That's why we are putting some weight value, right? So now, how to solve this particular problem using weighted sum method? That we need to find, right? So before we are going to solve, you should know whenever a attribute is given to you, for example, cost is given to you, so you have to decide whether you have to minimize the cost or you have to maximize the cost. For example, you are, let's say, manager of a particular company. So you will always look into how to maximize the cost. But you are a customer. Customer point of view, we are looking for how to minimize the cost. Okay. So we assume in this particular problem, toughness index and yield strength need to be maximized. So I am representing by upper arrow. Upper arrow indicates that higher value is better. For example, TI case, if you look into which one is a higher value, or alternative 3. YS case, which one is higher value? Again, alternative number 3. So that is better. But the density and thermal case, minimization is better. So fast to objective case, maximization is better, means maximum value is better. Second to case, the minimum value is better, right? Now, interesting part is that we call if the value is higher. Okay, for example, I told you TI and YS case, we need to select the highest value. We call these attributes as beneficial attribute. In MCDM terms, we call them as beneficial attribute. T and T case, we have to minimize. So we call that as non-beneficial attribute. So our objective is to maximize the beneficial attribute and minimize the non-beneficial attribute. Okay. So let us see how to solve. Yeah. Now here you can see the first step of WSM method is that you have to find with respect to each and every attribute which one is the best value. For example, in this case, if you look into the toughness index, which value is better? 770 is better because his objective is to maximize. So I am choosing the highest value. YS case 1365 is the is highest value, so that is better. D case, which one is better? D case, we have to choose the lowest value. The lowest value among 1 to 7 is 2.68. So I am picking that particular value. T case, I am choosing 9.4. Okay, that is the minimum value among all the 7 alternatives. So if the value is to maximize, you will choose the highest value. But if it is the objective is to minimize, then you will choose the lowest value. So here you are given these 7 alternatives, 4 attributes, and weight is 6231 respectively, and performance measure values are 75.5, 420, like that it is go on up to 19.9. So why actually I have highlighted these values? Because based upon this value, you have to do the normalization. Okay. So if it is a beneficial attribute, so what you will do, you can find the normalized value x, okay, by taking that particular value which is given here divided by x max. Okay, for example, if I want to normalize this particular value, I'll take that value, that is 75.5, divided by maximum in that particular column. Maximum in that particular column is 770. So whatever value you will get, that we call this a normalized value. Why we are doing this one? Because if you divide 770 by 770, okay, so you will get this value is 1. So the objective of normalization is to scale the values in a particular range. So we scale the values in the range of 0 to 1. Right? Similarly, in the second column case, what you will do? This 420 case, it is 420 divided by 1365. Next value is 91 divided by 1365. And the third value case, it is 1365 divided by 1365. So you will get here 1. Okay, this is all related to the beneficial attribute where higher value is better, right? So what about non-beneficial attribute? In the non-beneficial attribute, you can normalize by taking x mean. Okay, for example, D and T is non-beneficial attribute. So if you want to normalize the first value, what is the value here? 2.8. So what you have to do? You will take x minimum. X minimum is here. Minimum is 2.68. So if you want to normalize this particular value, you will write this value as 2.68, which is minimum value, divided by this particular value 2.8. So that will give you a value in between 0 to 1. Because 2.68 case, it will be 2.68 divided by 2.68. So you will get the value you will get is 1, right? So 7.9 case, what you will do? You will write 2.68, which is x minimum, divided by 7.9. Similarly, 8.53 case, you will write 2.68 divided by 8.53. Okay. So in this way, you can normalize a non-beneficial attribute. Similarly, T is also a non-beneficial attribute. As T is a non-beneficial attribute, so you will write x minimum is 9.4 divided by a particular value. So in this case, you will go for 9.4 divided by 21.4. Then in this case, it is 9.4 divided by 22.1, 9.4 divided by 16.9, 9.4 divided by 15.4, and 9.4 divided by 9.4, and so on. Like that, you have to normalize all the values in the range of 0 to 1. Only note down here, the beneficial attribute case, you are using this particular formula to normalize. Non-beneficial case, you are taking this particular formula. Beneficial case, x max is in x maximum is in the denominator part, but non-beneficial case, x min is the numerator part. Okay, in this way, you can normalize the values in the range of 0 to 1. Is it clear till now? Okay. So if you do 75.5 divided by 770, so you will get the value is 0.098. Okay. Similarly, I have simplified it. Whatever I am showing here by ratio, numerator by divided by denominator, so that I have solved and I have represented it in the form of numeric values. Okay. So you can see 75.5 divided by 770, we are getting 0.098. Similarly, the second value, that is 95 by 770. Okay, that is equal to 0.123. Okay. Now you have normalized all the performance measure values, right? Similarly, you have to normalize all the weights. How to normalize all the weights? So let us calculate the sum of weight. Sum of weight, if you find, it is 6 plus 2 plus 3 plus 1. So you will get the value is 12. So the first weight can be normalized as 6 by 12. Second is 2 by 12. 3 third is 3 by 12, and fourth is 1 by 12. So 6 by 12 you will get 0.5. Similarly, you calculate these values. That will be the normalized weight W. So this is the normalized weight. 0.5, 0.167, 0.25, and 0.083. Okay. Is it clear up to this? Yeah. So you can notice here also, in each and every column, you will get a 1. Okay, every column you will get 1. Because we are normalizing. Normalizing means maximum value is 1. So when you are dividing a value with the highest value, or when you calculate minimum value, overall minimum value by a particular value, definitely you will get the maximum value is 1. You will not get any value greater than 1. So if you are getting any value greater than 1 means there is some mistake you have done in the method. Now, what we have done till now, we identified the beneficial attribute, we identified the non-beneficial attribute, right? Then we have normalized all the performance measure values. Then we normalize all the weights. So now all these values are in the range of 0 to 1. Okay. So what we can do here, now all these values are ready, then we can apply the process of weighted sum method. What is weighted sum method says? As I said, earlier you are doing 1 plus 2 plus 3 plus 4 plus 5. And now you have to multiply a factor. So for the alternative one, if you calculate the weighted sum, which is equal to 0.5 into 0.098 plus 0.167 multiplied by 0.308 plus 0.25 multiplied by 0.957 plus 0.083 multiplied by 0.439. Can anybody calculate and tell me what is the value we are getting here? So what I did, I am multiplying these values and I am making their sum. So can anybody calculate 0.5 multiplied by 0.098 plus 0.167 multiplied by 0.308, 0.25 multiplied by 0.957, 0.083 multiplied by 0.439. So please calculate and tell me what is the value. What is the value you will get for alternative one? Okay, the one answer came. So that is 0.376123. Yes, it is correct. Okay. So first alternative case, we are getting this particular value. Similarly, yeah, it's correct. So like that, you have to calculate for second alternative. In second alternative case, what you will do? You will take weight value 0.5 multiply with 0.123, 0.167 multiplied with 0.067, 0.25 multiplied with 1, 0.083 multiplied by 0.425. Okay, so if you do so, you will get some particular value. Okay, Similarly, you try with alternative 3, 4, 5, 6, 7. So I am showing you the values, but you can try and verify. So you will get the values like this 0.376, which we already got. If you solve others, you will get 0.358, 0.799, 0.398, 0.457, 0.447, and 0.320. Okay. So now you have to decide whether higher value is better or lower value is better, because you have two beneficial attribute and two non-beneficial attribute. Okay, two beneficial attribute case, higher value is better. Non-beneficial attribute case, lower value is better, right? So when you calculate, so you are neutralizing both, because you are calculating x divided by x maximum. In the case of beneficial attribute, we are calculating x mean divided by x. That is for non-beneficial attribute. So all these things, by whatever calculating, ultimately non-beneficial attribute case, we are taking x mean by x. Okay, x mean divided by x, right? So the range is 0 to 1, right? So as you are calculating x mean by x, after converting it to a normalized value, obviously higher value is only better, right? So whether it is a beneficial attribute or non-beneficial attribute, after doing the normalization, all will be converted to a beneficial attribute. That's why higher value is always suggested. So here you can see which one is higher value, which alternative is having higher value. Check once.
Third.
You have 7 alternatives. Out of 7 alternatives, yes, third alternative is the best one. So I will choose the third alternative's material for the cryogenic storage tank for transportation of liquid nitrogen, which I showed you initially. We have to select the materials. So these 7 are what? Properties of 7 different materials. So you have to choose one particular material for cryogenic storage tank for transportation of liquid nitrogen. So we found that third is the best material. Okay, out of all the 7 materials what is given here, so we should suggest the third option. After that, not only your objective is to choose the best one, but your objective in the MCDM problem or MADM specially is to rank the alternatives. So if you rank the alternative, this is rank 1. Next, I think you will get 457, if I am correct, it is 2. Then 447, it is 3. Then I think 398 is 4. 4th rank. Then 376 is 5th rank. 358 and 3. Okay, this is 6th rank, and the last one is the 7th rank. So this rank is going to come. You can see in the next slide the answer. Okay, and compare. What is coming is 5614237. 5614237. Okay. In this way, the weighted sum methods works. Is it clear? Okay. The next method that we are going to discuss, that is called as weighted product method. So product method is same as our weighted sum method. Okay, but only the word is, here it is sum, there the word is product. Okay, so what we are going to do, we'll take the performance value and we'll take the weight value. Like here also we take the weight value and performance value and we multiply that. Rather than multiplying, here it is product, right? So what product means, what we are doing, 0.098 in the product method, you will write 0.098 to the power 0.5 plus 0.308 to the power 0.167, 0.957 to the power 0.25, 0.439 to the power 0.083. So only earlier you are multiplying, here you have to find power. This is the only difference between weighted sum method and weighted product method. So you can see here, yes. So it is same as with WSM, but weighted product is used instead of weighted sum. So you can evaluate the first one, 0.098 to the power 0.05 plus 0.308 to the power 0.167 plus 0.957 to the power 0.25 plus 0.439 to the power 0.083. So can you calculate and confirm me whether you are getting 3.0575 or not? Check once.
Sir, how you calculated weight in this case?
Weight is same as the previous method. So earlier weight is I think 6231. So we calculate sum of the weight. Sum will come 6 plus 2 plus 3 plus 1, that is 12. So weight is normalized as 6 by 12, 2 by 12, 3 by 12 and 1 by 12. 6 by 12 you are getting 0.5, which is written here. 2 by 12 is I think 0.167, 3 by 12 is 0.25 and 1 by 12 is 0.083. So in this way you can calculate the weight of the attributes. And here you can see some of the weights is 1. You are calculating normalization. Normalization case you have to make it 1. Are you getting 3.0575?
Yes, sir.
Yeah. So like that, if you are getting in this case, so other case also I have written the values, you can cross check. Okay. So that is the weighted product value of 7 different alternatives. The last column shows the weighted product value of 7 different alternatives. So if you look into the 7 different alternatives, as I said, highest value is better because those values are non-beneficial, we convert it into beneficial. So in this case, which one is the highest value? So I think 3.2386, you can see it is the highest value. So it is given as rank 1. Then another 3 point something is there. So I can consider this is the second best. And this is the third best. And let's say this one is the fourth best. This one is the fifth best, sixth best, and this is the seventh best. Okay. So can anybody make a observation in WSM and WPM? In WSM case, which alternative is better? WSM case, you go back. Which alternative is better? Third alternative, right? Third alternative got first rank. But in this case, which one you got first rank? Fifth alternative. Okay. One case you got third alternative, another case you got fifth alternative. Now a question arises in your mind, right? For example, I'll apply X method, then I may get the first alternative is better. Somebody can apply Y method, and let's say fourth alternative is better, right? We have seen in this case, WSM case, it is saying third method is better. WPM, it is saying fifth method is better. So if I apply different methods, If it is coming the same, it is fine. If you can apply the 8 methods, and let's say out of 8 methods, 5 methods is saying third is better, then you can make a consensus by saying majority of they are saying third method. So let us say that third method is better. But if they give like this, the first method and the fourth method is better, so you will not get any consensus, right? You will not make any conclusion, because third is having one vote, fifth is having one vote, first is having one vote, and fourth is having one vote. So how to make a conclusion? That is really challenging. Can anybody guess how to make a conclusion in this case? How to make a conclusion? You understood what problem I am saying here? What is the problem? Is it understood? The output of each and every method is different, right? So WSM, WPM case, we are getting third and fifth alternative is the best. Similarly, if we go for X method or Y method, you may find some other alternative is best. So in order to take a complete decision, right, you need, if all of them are saying that one method is better, then we can go for it. But if they are saying different one, so it is difficult to make a conclusion. So in order to do this, we do sensitivity analysis. What is sensitivity analysis? So this method says that you alternate the weight. For example, I'll alternate 0.5 weight to here, 0.1667 to here. And let's say I'll keep D and T, and I'll run the algorithm. Similarly, note the result. Once you exchange the weight of Ti and Ys, what you will do? You will apply this particular approach and find which alternative is best. Once it is done, you exchange Ti with D. You exchange the weight. Okay. They apply a particular method. Find the best alternative. Like that, you have to choose again 0.5 and 0.083. That is Ti and Te. Exchange the weight and calculate it. So if the method is a robust method, in all cases you will find one of the alternative is only the best alternative. Okay. If it is not sensitive to your input, then you can make a conclusion that yes, that particular alternative is best. Okay. In that way, actually, we make a conclusion that which alternative method is which alternative will select by exchanging the weights. So in order to calculate the robustness of system, this is an important measure. Okay. So here is the conclusion. WPM case, we found the fifth alternative is best. So we have covered two methods. One is WSM and WPM. We left with another 4 methods. So the next method we are going to discuss, that is called as Pramiti. The method is called as Preference Ranking Organization method for enrichment of evaluation. So in the previous case, what we have seen in WSM and WPM case, we are normalizing the weight, right? How you are normalizing the weight? You are calculating the sum of the weights. So you can see here, sum of the weights also, we calculate here, like previous method, we
Sir,
got the value is 12.
how
Yeah,
we got this 6231?
it is random, madam.
Random.
It is completely random. Yes, random only.
Okay, sir.
These values, all these values are random. Even if these performance measures values also, we generate randomly. But actually, these values are belongs to, whenever you go for any real life example, you have to collect this. Right. For example, here I am showing you this particular attribute has more importance in comparison to other attributes, right? So you have to actually make a assessment that which attribute is more important. So you want to purchase a particular product, you have different attributes, right? One of the attribute may be cost. Suppose you are much worried about cost, so you can put more factor or more weight value to cost. If cost is not at all a matter, you can put more weight to quality, right? So these values you have to make an assessment and do it. But for the example proposed, we have generated these values randomly.
Okay, sir.
Yeah. So we have calculated the sum of weights. Sum of weight is 12. So what we are doing, after finding the sum of weight, I am dividing the sum of weight with all the individual weights. So 6 by 12, you will get 0.5. 2 by 12, it is getting 0.167 and so on. It is same as the previous one. So there is no need of any discussion. But here, I have taken only 4 alternatives. I have not taken 7 alternatives because this method is too complex when the number of alternatives are huge. So I am taking only 7 different alternatives. So what I'll do, I'll compare one alternative against other alternative. Okay, I'll compare one alternative against another alternative. So I'll create with respect to a particular attribute, I'll create a matrix and in which I am comparing one alternative against another alternative. Similarly, I'll take another attribute, perform the same, comparing one alternative with other alternatives. Similarly, I'll take D and TE, compare one alternative with another alternative. Let us see how to do this comparison. Okay. So what it says, each alternative is compared with other alternative with respect to attribute. So when you make a comparison, if the value is better, then you put 1 in the matrix. But if the value is not better, so you put 0 in the matrix. Right. For example, I am taking the first attribute, which is called as toughness index. So whenever we are choosing a particular material from the cryogenic tank, toughness index is more important, right? So it is a beneficial attribute. So these are the values what I have given here: 75.5, 95, 770, and 187. So I have written these 4 values. Okay. So now I am comparing one alternative with another alternative. So if a alternative is compared with itself, so you cannot make an assessment. So you can see the principal diagonal case we put dash. That is not applicable. You cannot compare one alternative with that alternative. Right. So now if I compare, so we are taking TI is the first attribute, right? So when you compare A1 with A2, what is the value of A1? A1 value is 75.5. A2 value is 95. So you have to find 75.5 is greater than 95 or not. 75.5 5.5 is greater than 95 or not. When you take this one, A1 is compared with A2. This is A1 value, this is A2 value. So I am comparing A1 value with A2 value. Okay, is the objective is to maximize, or it is a beneficial attribute. So higher value is always better, right? So 75 is not greater than 95. So I am putting this value is 0. On the other hand, when you take A2, A1, because this is a square matrix, right? So if you fill 50%, I can fill another 50%. So A to A1 case, it will come 95 is greater than 75.5. Yes, it is true. 95 is greater than 75.5. So this value is 1 because it is true. We compare it is 1 means A2 is a good alternative in comparison to A1. It is 0 indicates that A1 is not a good alternative of A2. Right? So you can see here A1 to A2 it is equal to 0. A 75.5 less than is 95. That means A1 is inferior to A2. A2 A1 case it is 1. As 95 is greater than 75.5. Right? Similarly, if you take A1, A3, this particular value, A1, A3, what is the performance value of A1? Performance value of A1 is 75.5. Performance value of A3 is 770, right? So is 75.5 greater than 770? Is it true? True or false?
False.
False. That's why we are putting the value here 0. But when you take A3 to A1, if it is false here, here it is true, right? If I take A3 first, then A1, so I'll check 770 is greater than 75.5 or not, right? So in this case, it is true. So I am putting a value 1. But don't compare the same alternative with same alternative. Okay, itself comparison is not possible, right? So I put hyphen. Okay, so now it is clear how to do for toughness index. Similarly, you can calculate for okay. Similarly, you can calculate for the second one, that is YS. Okay, so because both are beneficial attribute, the process is same. But D and T case the procedure is different because they are non-beneficial attribute, where your objective is to minimize, not to maximize. Okay, let me tell you how to do in the case of D. So D objective is to minimize. Minimize means smaller is the better value. If the value is smaller, that is a better value. So when you compare A1 with A2, let me take A1 and A2. What is the performance value of A1? That is 2.8. Performance value of A2, that is 2.68. So when you compare A1, A2, earlier if you remember, I am comparing A1 is greater than A2. That is A1 is inferior to A2 or not, I am checking. Okay. Or I am checking 2.8 is greater than 2.6 because that is a beneficial attribute. As it is a non-beneficial attribute, I will check the less than. Okay, whether A1 is inferior to A1 is smaller than A2 or not. So in this case, it is not true. So I am putting the value is 0. But when I take A2 and A1, A2 value is 2.68, A1 value is 2.8. So if I calculate less than, it is true. So that's why A2 to A1 value, it is 1. So in the beneficial attribute case, you are checking greater than. If greater than is true, you are putting 1, otherwise it is 0. Non-beneficial attribute case, you are checking the less than. If it is less than, then it is true. If less than is true, then you put 1. If less than is not true, you put 0. Okay, let us see another one. Suppose I am choosing A3 with A4. Okay, A3, A4. So A3 value is 7.9, A4 value is 7.9. So in this case, there is a tie. 7.7, 7.9 is not less than 7.9, right or not? Neither A4 is also not less than A3. So these values are not determined. So A3 to A4 case also we are putting hyphen. A4 to A3 case also we are putting hyphen. Okay. But see another case. Suppose I am taking A to A4. A2 value is 2.68. A4 value is 7.9. Is 2.6 less than 7.9? Yes or no?
Yes.
Yes, 2.6 is less than 7.9. So A2 to A4, this particular color, this particular element will write 1. But when you go for A4, A2, that is 7.9 and 2.68. So when I take 7.9 is less than 2.68, it is not true. So that means A4, A2 location, I'll put? I'll put 0. Okay. I hope you understood what we are going to do in the beneficial attribute, what we have to do in the non-beneficial attribute. I'm not explicitly showing for YS, which is a beneficial attribute, and another one is T, which is a non-beneficial attribute. So what you can do, if you every case you will get a matrix like this, 0, 1 matrix. So I am summarizing all the matrix into 1. So this matrix you got in the case of toughness index. This matrix you got in the case of YS. This matrix you got in D. This matrix you got in T. Okay, toughness index. Right. Now, once you get this one, then you have to combine. Right. How to combine? So let us call these elements, this matrix. I want to combine these 4 matrix. Okay. So I am taking the combined matrix, I am calling as P matrix. So in P matrix, also it is a 4 cross 4 matrix. These all are 4 cross 4 matrix, right? So I am calling this element as P11, P12, P13, P14, P21, like that it is up to P44. Right. Now if you go for P12, calculation of P12, how to do this one? You will take the corresponding location in Ti, multiply with the weight factor. So 0 into 0.5. Similarly, you will come to this particular matrix. You will take this value multiplied with the weight value. That means 1 into 0.167. In the third matrix case, you will take 0 multiplied with 0.25. Fourth matrix case, you will take 1 multiplied by 0.083. Anyhow, it is multiplying with 0 means it is vanished. So 0.167 plus 0.083. This factor and this one, 0.167 plus 0.083. So if you sum it, you are getting the value is 0.25. Is it clear? Similarly, you have to calculate for P13, P14 up to P44. Is it clear how we are doing this one?
Yes, sir.
What I did, I am summarizing you. First, I have taken, you know, there are 4 alternatives. Their values you know. You choose one alternative. Okay, sorry, choose one attribute and compare all the alternatives with respect to that attribute. So if there are 4 attributes, you will get 4 different metrics. If there are 5 attributes, you will get 5 metrics. Then you have to combine that matrix. So the resultant matrix which you are getting, that is written here. This is the matrix you are going to get. Okay. Then what we are doing, we are calculating row sum, another is we are calculating column sum. Why you are calculating row sum and column sum? Row sum is considered as a leaving flow and column sum is calculated as a entering flow. So you want to see in this particular method how many attributes you are giving more importance since they are entering. Like if you go for this particular problem, it is a cryogenic problem, right? I mentioned. So what is the entering flow and what is the leaving flow? That is more important. So that is the significance why you are calculating the row sum and column sum. So if you calculate row sum here, 0.25 plus 0.25 plus 0.25. So it is 0.75, right? But A2 case, it is 0.75, 0.25 and 0.25. So it is 1.25. Like that you can find the row sum. Calculate the column sum. Column sum can be calculated like this 0.75, 0.75 and 0.75. So the value is 2.25. Similarly, if you calculate for alternative 3, A3 column, then 0.25, 0.25 and 0.083. 2525 is 0.5. 0.5 plus 0.083 is 0.583. Okay. So once you determine the row sum and column sum, you have to find row sum first row minus first column. RS minus CS indicates first row minus first column. So 0.75 minus 2.25. So I am getting the value is minus 1.5. Another is 1.25 minus 1.75. You will get the value is minus 0.5. 2.167 minus 0.583. You will get 1.584. 1.587 minus 1.167. You will get 0.416. And here you have to find the maximum row sum and column sum. Okay. So the maximum row sum and column sum you are getting in the case of alternative 3. So if you remember, while I am comparing WSM and WPM method, if I go to that slide, yeah, I told you WSM case, third alternative is best. WPM case, the fifth alternative is best. Right? Anyhow, here we have not considered fifth alternative. Right? Here we have not considered fifth alternative. We have considered up to fourth alternative. So this particular method also says that which alternative is better? The third alternative is better. So now you have two votes for third alternative. But once you take fifth alternative only, then only you can say that. Right? But you try to execute it with the five alternatives. If you execute it, then you will come to know whether it is coming third or fifth. Anyhow, out of these four alternatives, third is best. But when you take the fifth one, anything can happen, right? So in this way, you can calculate and make a decision in Prometheus method. So is it clear? Okay, you can see also why we are choosing this value that is written here. Why we are choosing the maximum value. Why we want to make A3 is the best alternative. The reason is that the process of normalization, whatever you are doing, maximize or minimize. Right? Normalization case, you are going for maximization or you are going for minimization. Earlier you are calculating x max x divided by x max, or you are doing x mean by x based on beneficial non-beneficial attribute. So after normalization, all the value reduced to maximum. That's why we are selecting the maximum value. We are not selecting the minimum value. Okay. But recently, we have also improved the performance of the Prometheus algorithm. So if you go to one of my research article, you can find the performance is improved compared to the Prometheus algorithm. So what is the improvement that I'll tell you here? For example, you see here, you will find what is the difference between Prometheus and our improvement over Prometheus. So while you are comparing 75.5 with 95, 75.5 is greater than 95. It is false. That's why you are getting value 0. Okay. Next, if I compare, if I go row wise, then 75.5 is compared with 770. Right? That case also we are getting 0. Right or not? Similarly, 75.5 is greater than 187. You are getting 0. Right or not? So in this case, we represent everything in the form of a 0-1 matrix, which is not fair. For example, you can see whether the value is close to 75.5 or very far away from 70.5, you represent both value as 0. So when you compare two different alternatives, you should not make a judgment that either it is greater or less. How much greater and how much less, that also you need to find. Otherwise, it may happen that, let's say, one value in this particular attribute case, 75 is less than 95. Another case may be, let's say, in the case of, let's say, YS case. Okay, this alternative, we are comparing here alternative A1 with A2, right? Similarly, for another attribute, when you compare A1 with A2, let's say A2 is better. Assume that A2 is better. Anyhow, in this case also A2 is better. So let us take A1 is better. A1 is better. So one attribute case, it is showing A2 is better. Another case, it is showing A1 is better. So there is a tie. So if you find how much time it is better, what is the relative importance, then you can actually make a judgment that whether alternative 1 is better or alternative 2 is better, which is not considered in the Prometheus. So in our research article, what we have done, we have considered this Prometheus approach and we have shown the relative importance. So that relative importance will help you to, when you are comparing one alternative to another alternative, we are getting a factor. We are not getting 0 and 1. So that factor will help you when you are calculating this P11 and P12. and so on up to P44. So that exactly the leaving flow and entering flow can be calculated. Okay, so that is the improvement which we have done over the Prometheus algorithm. I'll share the paper in the materials folder. Is it clear? If you have any question, you can ask. Okay. So the next method that we are going to discuss, that is called as Vicar. I already told you Vicar is a Serbian term. That's why that name is little bit odd. It is not written in English. Okay. This Vicar method is also known as for compromise solution. It is also called as compromise ranking method. Okay. So in Vicar case also, what we are doing, we are taking the same data with 7 alternatives, 4 different attributes, and weight value is 6, 2, 3, 1. And we consider first 2 attribute is a beneficial attribute, second 2 attribute is a non-beneficial attribute. Okay. And the process of normalization in the case of Vicar is same as WSM and WPM. How we are doing normalization with respect to WSM, WPM? How we are doing in WSM, WPM? You are selecting the maximum value, right? And divide all values with the maximum value. That means for toughness index, it is 75.5 divided by 770, 95 divided by 770, 770 divided by 770, 187 divided by 770, 179 divided by 770, 239 divided by 770, 273 divided by 770. So that is for the beneficial attribute. But when there is a non-beneficial attribute like D, so you will find the minimum one. Minimum one is 2.68. So it is 2.68 divided by 2.8, 2.68 divided by 2.68, 2.68 divided by 7.9, 2.68 divided by 7.9, 2.68 divided by 4.43, 2.68 divided by 8.51, 2.68 divided by 8.53. So let us see. The same method is WSM and WPM we are using. Okay. So now all the values are normalized. Okay. The same method we are using, nothing to worry. So after normalization, you know, I already told you what is the maximum value you will get. Maximum value always you will get is 1 in each and every column. The highest value will normalize to 0 and lowest value is greater than 0. Right. So in Beaker method, the first step says that you have to find the difference. What is the difference? The difference is nothing but the maximum value minus the minimum value. The maximum normalized value minus minimum normalized value will give you the difference. For example, if you look into the first column, obviously every case maximum value is 1 only. You have to find the minimum value also. Minimum value you find 0.098. So 1 minus 0.098. So you will get 0.902. Okay. Similarly, 1 minus 0.067. You will get 0.933. 1 minus the minimum value is 0.314. You will get 0.686. 1 minus the minimum value among all 0.425. We are getting 0.575. Okay. So first you have to find the difference. Okay. So once you find the difference, then the next step is to normalize the weights. The normalize the weight is same as the previous one. So what I am doing, 6 divided by sum of weight, that is 12. 2 divided by sum of weight, 3 divided by sum of weight, and 1 divided by sum of weights. Now all these values are normalized in between 0 to 1. Okay. So what we are finding in Beaker method is that Beaker method we are calculating the value of E. E is nothing but sum of W max minus X divided by max minus min. So you already found what is max minus min. That is the difference. Difference you already found 0.902, 0.933, 0.686, 0.575. I'm keeping the value as it is here. In the numerator part, you have to take maximum minus X and you have to take corresponding weight. So when you calculate here, W is 0.5, 0.167, 0.25 and 0.083. So you can see first term I am writing 0.65, 0.167, 0.25 and 0.083. Okay. And maximum value, maximum minus minimum, difference value that we are putting in the denominator. What else is there? Maximum minus X. So maximum value is always 1, right? We have seen here. I told you also, overall the maximum value is 1. So 1 minus you will take X. So these are the minimum things you have to take. What are the minimum things? You will take weight, you will take maximum value, minimum value and D. So these are common for everyone, common for all alternatives. So when you find the E value for the first alternative, so you have to put the E value 0.098. Okay, then you calculate E value, you will put 0.098, 0.308, 0.957 and 0.439. This value in place of X. Rest value is as it is. Okay, so if you do so, you will get the value is 0.7205. So I am telling you again what we are doing here. We have calculated the normalized weight. We have calculated the maximum value of each and every column, minimum value of each and every column, and we calculated the difference, that is maximum minus minimum. These values are common. Only I am taking the first alternative to generate a E value, which I represent here as E1. Similarly, I will calculate E2 value. I will calculate E3 value. If there are 7 alternatives, I will find 7 different values, right? And these values we are putting in place of X, and I am summing all the values. So let us see for the second alternative. Second alternative case, it is 0.5 weight value, then max minus X, that is 1 minus 0.123 divided by D, that is 0.902 plus 0.167, 1 minus 0.067 divided by 0.933. Similarly, 0.25, 1 minus 1 divided by 0.8686. Similarly, 0.083, okay, 1 minus 0.425 divided by 0.575. So you will get the value of E2. Okay, like that, if you go proceed, you will get the value for E3. Here you can see E3. Okay, E3 case you can see it is matching with the maximum value because that particular alternative achieves best value for 2 different attributes. That's why the value is 1. So that entire term is going to vanish. Okay. So you are getting 0 plus 0. Right here 0 plus 0. Why you are getting? Because that particular alternative is the best alternative for that particular attribute. That's why you are getting 0. Similarly, we calculated for E4, we calculated for E5, we calculated for E6 and E7 because we have 7 different alternatives. All these values are summarized here. Okay. So these are the E values. And once you find E value for all the alternatives, you have to find which value of E is minimum and which value of E is maximum. So we found that alternative 3 case E value is minimum, alternative 7 case E value is maximum. Okay. And You are calculating this with respect to four objective, right? One is Ti, another is Ys, is another attribute, another is D, another is T. So four alternatives. Sorry, four attributes. With respect to four attributes you are finding. So you have to find in which attribute case you are getting the maximum value. So you are getting 0.5 is the highest value for Ti. That's why I'm writing 0.5 here. So in this case, I'm getting again the highest value in the case of first attribute. So I'm writing 0.4861. Similarly, if you write the value for seven different alternatives, you can find again what is the F mean, that is the minimum value among in the F column and maximum value in the F column. Okay. So after finding this E and F value, what actually we are going to do? You have to determine the value of P. So P is calculated based on this particular formula. Okay, in which we are taking in the first term, it is concerned with E column. So B is a you can say threshold kind of thing where we are taking 0.5. So ultimately 1 minus B becomes 0.5. B is 0.5 means 1 minus B is 0.5. So E minus E minimum divided by E max minus E minimum. So what is E? E is nothing but, in this case, if you see E is 0.7205, E minimum is 0.3050, E max minus E minimum is 0.83 minus 0.3050. Similarly, when you evaluate these particular terms, 1 minus B becomes 0.5, F minus F minimum, F value is 0.5 minus F minimum, F minimum is 0.2409 divided by F max minus F min. Okay, you will get this particular term. So here you are calculating, you are getting the value is 0.8909. So overall, if you look into this calculation, you should know what is the main moral behind this calculation. This particular E says that who is best overall, and F column is saying which particular attribute is best, right? So just like a local search and global search, right? You are achieving the global search. At the same time, you are also looking for a particular area where you can get better solution. So there is a trade-off. That trade-off is taken care by this B and 1 minus B, right? So once you determine these P values, okay, you have to choose the minimum value. Here, we are not choosing the maximum value. We are choosing the minimum value. So minimum value we are getting in the case of alternative 3. Okay, so alternative 3 is said to be the best alternative. Similarly, the next lowest value you can see in P column, we are getting, I think, in the case of 0.6273. So we consider that is a second best alternative. Similarly, 0.6660 is considered as third alternative, third best. This is the fourth best. This is the fifth best, the sixth best, and this is the seventh best alternative. So in this way, the Beaker algorithm works. So let me tell you how overall process again. So what we did here, like WSM and WPM method, we calculate, we normalize the values, performance measure values, including our weight value. Okay, all the values are normalized. And in this case, we focus on difference. The difference is nothing but maximum value minus minimum value. Okay, maximum value minus minimum value. Okay, so once you determine this one, you calculate the E value. Okay, E value will be calculated based on this particular formula, right? Once you calculate E value for all the alternatives, okay, then you will calculate the F value. F value is the individual attribute value, whereas E value is the overall value. Then you have to calculate the P value by making a trade-off between E value and F value. And for the alternative where you will get the minimum value, that will be opted as the best alternative. Okay, so this is the process of Beaker. Okay, there is another process for MCDM that is called as Topsys. Okay, Topsys is also one of the popular method. Okay, many research articles, recent articles also talks about Topsys. Topsys stands for Technique for Order Preference by Similarity to Ideal Solution. So what it is doing here, it is taking a particular attribute and set of alternatives or set of alternatives and their performance measure value with respect to an attribute. For example, Ti is an attribute. So for 7 alternatives, these are the performance values. So we calculate Ti square. Ti square is 75.5 whole square. We are getting 5700.25. Similarly, in this case, we are getting 95 whole square. You will get 9025. Similarly, find the square of all the performance measure values of the alternatives with respect to the attributes. Then you calculate sum of Ti square. Sum of T of Ti square, you are getting 806285.25. So if you calculate the denominator is nothing but root over of summation of Ti square. So summation of Ti square, you got this one. If you find its root over, we call that as a denominator. So denominator we are getting here is 897.9339. Okay, that is for the first. That is for the first attribute. Similarly, you have to determine the denominator value for all other attributes. So can anybody calculate the denominator value of Ys? That is yield strength. That is second attribute. Can anybody calculate the way we have calculated the Ti? Okay, denominator for Ti. Similarly, can you calculate the denominator for Ys? Calculate it. What you have to do? You have to calculate 420 square plus 91 square plus 1365 square plus 1120 square plus 800 square
Three,
plus
four, five,
1190 square and it is 200 square.
nine,
Okay,
10.
200 square, right? So if you sum it, you will get, if you calculate the sum, you will get a value and you have to take root over. So calculate it once and tell me what is the value we are going to get. Okay, if you calculate the sum is calculated as 5524031. Okay, that is nothing but the sum is nothing but Ys square, all Ys square. But what do we have to find? We have to find denominator D. So denominator D is nothing but root over of summation of Ys square. So you have to find root over of 5524031. How much you will get? Root over of 5524031. So you'll get the value is 2350.3257. Similarly, what you have to do? You have to find summation of D square. Okay, you have to calculate summation of D square. So let me show you. Yes, this we have already got 2350. Okay, we have calculated the sum of all ys. Okay, and we have calculated root over of summation of ys square, that we are getting 2350. Okay. Now in the next step, what we are going to do, we have to again calculate for non-beneficial attribute. Non-beneficial attribute case, you have to take these all values, you have to take their individual square and root over. So you will get that particular value is 304. Some value is 304, root over 304, you will get 17 point something. Similarly, for T, you have to calculate 21.4 square, 22.1 square, like that up to 19.9 square. Okay, and it's root over. So root over you are getting is 2055.96. Is the sum value we are getting, and root over you will get is 45. Right? So once you get this particular value, next step is to do normalization. How to do normalization? The normalization is based upon this denominator value. We are calculating this denominator value to make the normalization. For example, in this case, you are getting denominator is 897.9339. Okay, 897.9339. So what you will do, how to normalize this particular value? You will write 75.5 divided by 897.9339. Similarly, second value is 95 divided by 897.9339. So on up to the last value is 273 divided by 897.9339. Okay, like that you have to calculate. That's why we are calculating the value D. Okay, so this process I have written here, and normalization of weight is same as what we discussed earlier. Now all the values are normalized. Okay, so the next process is that you have to apply the similar way what you have done in the case of WSM. What we have seen in WSM, you are multiplying 0.5 bit 5 bit 0.0841, 0.167 bit 0.1787, 0.25 bit 0.1604, 0.083 bit 0.4720. So you will get this matrix. Okay. So this is same as our WSM. Okay, only the normalization process which you have used, that is different. We have calculated the denominator, right? But in the case of WSM, we are calculating x by x max for the beneficial attribute, or x min by x for non-beneficial attribute. So except that, the process is same. So once you calculate this one, okay, these are the values that you are going to get. Then you have to calculate SP and SM. Okay, how to calculate SP? SP is nothing but in each and every normalized value, in each and every column, after normalization, in each and every column, you can find which value is the highest value. So in this case, the highest value is 0.4288. In this case, the highest value is 0.0970. But these are non-beneficial attributes, right? In non-beneficial attribute case, we are taking the minimum value. So SP is calculating by finding the difference between the current value means for the alternative one, the value is 0.0421 minus 0.4288 whole square. Similarly, 0.0298 minus 0.097 whole square, 0.0401, 0.0384 whole square, 0.0392 minus 0.0172 whole square, and its root over. So you will get the value is 0.3931. Similarly, you have to calculate SP value for all alternatives. Okay. But when you calculate SM value, okay, SM value is calculated based on the lowest value. Okay, so lowest value for beneficial attribute, highest value for non-beneficial attribute. So which I have shown in red color. So you can see 0.021 is the worst value in the first column, where 0.03, 0.0122 is the highest value in the third column. Okay, so that will give the SM value, right? So once you calculate this SP and SM, so P can be calculated as SM divided by SM plus SP, where P is nothing but the difference between the current value and the best value, where M is the difference between the current value and the worst value. So once you calculate P for all the alternatives, you have to select the alternative that is having higher value for P, highest value of the P. So in this case, 0.8395 is the highest value. So this method also suggests that alternative third is the best one. Okay. And similarly, you can rank other alternatives. If I ask which one is the second one, you can find the second best value. Best value is 0.2832. So that is 0.2832 is the second best. Okay, third is 0.2677 and so on. Okay, so that in this way you have to calculate in the Topsys algorithm.
Sir, what is
Any doubt?
SP and SM?
What, madam?
SP and SM, I lost the connection that time.
SP is calculated based on, suppose you are taking the first alternative, right? First alternative, your value is 0.02, 0.0421. Okay, the difference between 0.0421 and the best value in that particular column, the difference between these two value. Similarly, you have to calculate difference between all other attributes value and its root over. So let me show you here. Here it is more clear. So here, in order to calculate SP, it is 0.0421 and 0.4288 whole square. 0.0298 plus 0.0970 whole square. 0.0401 and 0.0384 whole square. Here I am taking minimum one because it is a non-beneficial attribute. Beneficial attribute case, you have to choose the maximum one. Non-beneficial attribute, you have to choose the minimum one. So that is actually SP. Okay, similarly, you have to do these two. And SM is nothing but you will find the worst value in each and every column. Here we are calculating with best values. These are the best values, right? Similarly, in this case, we are calculating with worst values. Okay. And once you have SP and SM value, you have to calculate P value as SM divided by SM plus SP. And the alternative that contains, okay, that holds the highest value of P is the best alternative. So we found that the third alternative is the best alternative. Okay. So in most of the cases, we are finding the third alternative is the best alternative, right? So there is another MCDM method that is called a GTMA. It stands for Graph Theory Matrix Approach. Okay. So it is a logical and systematical approach which originated from combinatorial mathematics. So we have studied in mathematics something called as determinant or matrix. That concept is used here. Why GTMA is a very famous? It is a complex method. It is not an easy method. It is widely used because it helps to analyze and understand the system as whole by identifying system and subsystem up to the component level. Okay, so if you go for GTMA method, it is not only analyzing in a system level, but a system contains subsystems. Subsystem again contains subsystems. So while it is analyzing the things, it is considering everything. That's why this method is working in the component level. So GTMA helps in selecting the most suitable choice from among a large number of alternatives for a given problem. Matrices are provided as a simple and very elegant means of representing a graph. A graph can be easily represented in the form of a matrix, right? For example, if I take a graph A, B, C, okay, so you can represent in the form of a matrix, right? You can take A, B, C, and you can take here in the column wise also A, B, C. You can, if there is a connection between two different node, then you can say it is one. If there is no connection, then we represent it by 0. Okay, so this is the way you can represent a matrix into the graph. So it also uses that particular method to solve the problem. So see, I am taking the same problem. Okay, again I am considering the Ti and Ys is considered as beneficial attribute. D and T I am considering a non-beneficial attribute, right? So the process of normalization is same as our WSM and WPM method. You will choose the higher, you will choose the you will choose the highest you will choose the highest value for beneficial attribute and the lowest value for non-beneficial attribute like the previous one. And once you normalize these values, okay, once you normalize these values, here the weight calculation is different. Here performance measure values are calculated, normalized based on WS and WPM. Okay, the way we have calculated for WS and WPM. Okay, so the same way we are calculating for GTMA, but weight is our 6231, right? So that is in the case of weight, the calculation is different. Normalization of weight is different. So how to calculate the weight? So weight case, we took a matrix. Like I'll take Ti, Ys, D, and T, and I'll take a square matrix. Ti, Ys, D, and T. Okay, where the principal diagonal is, you will not define. Okay, because Ti to Ti it is not allowed. So if you calculate the relative importance matrix between Ti with Ys, so Ti is 6, this 6231 is also 6231. So when you calculate the relative importance between Ti and Ys, so it is 6 by 6 plus 2. But when you calculate Ys with T, for example, you want to find Ys with Ti. So the value is 2 divided by 2 plus 6. Okay, like that you can calculate the relative importance matrix between all the attributes, right? And you can fill this particular matrix. So this is the whole matrix. You can see the whole matrix here. We are calculating Ti divided by Ti plus Ys. Here also we are doing okay, Ti divided by Ti plus Ys. In this case, Ti divided by Ti plus D, Ti divided by Ti plus D. Okay, so we are calculating like this. Similarly, you can calculate for Ys and D and T. So what we are going to do now, you can see the principal diagonal case we have not calculated, right? I have not mentioned anything. So in that location, you have to put one alternative. Okay, for example, what is our first alternative? Our first alternative values are 0.098 for first attribute, 0.308 for the second attribute, 0.957 third attribute, and 0.439 for fourth attribute. So these values I will put here. So it will look like, you can see here I am going to put these values, right? So it looks like this particular matrix, right? So how to solve this one? In order to solve this one, you will go the process like a determinant. Exactly, it is not determinant, but a process like determinant. So how to solve it? So I'm taking 0.098, and in determinant case, we are not considering the same row, we are not considering the same column. Rest of the element I am writing here, right? But in the second case, when you take 0.308, okay, sorry, when you take 0.75, Okay, you will put the corresponding column of and corresponding row of, and you will write 0.25, 0.30333, 0.143, 0.4, 0.957, 0.25, 0.667, 0.75, and 0.439, which is represented here. But determinant case we are writing minus, but in this case we are writing plus. That's why I told you the process is similar to determinant, not exactly same. Similarly, I'll take 0.667, I'll log this column and row, and I'll write the rest of the part. On the other hand, I'll take 0.857, I'll make the row and column off, and I'll write the rest part. So in this case, we are getting the value is 0.8182. If you solve this particular determinant, you will get the value as 0.8182. So online calculators are there. You can use online calculator to solve each and every determinant. Okay, if you don't want to solve manually. Similarly, what I'll do, I'll take the second alternative. These are the four different values of alternative 2. Okay, I'll put alternative 2's value in the matrix. So I will, once I'll put, then I'll follow the same procedure. What is the procedure? That is 0.123. So let me write here 0.123. Then you can take 0.667, 0.4, 0.667, 0.61, 0.75, 0.333, 0.25, and 0.425. Okay, plus 0.775, then 0.25, 0.4, 0.667, 0.333, 0.143, 0. Sorry, this is 1, this is 0.25, 0.75, and 0.425. Okay, then again plus 0.667, we'll take 0.25, 0.333, 0.143, then 0.07, 0.6, 0.333. Okay, and the last column, that is 0.0667, okay, 0.75, and 0.425. Okay, it's determinant. Plus the last one is 0.857, 0.25, 0.333, 0.143, 0.067, 0.6, 0.333, then 0.66, 0.4, 1, and 0.25. So if you solve these four different metrics and multiply with the corresponding value, you will get value as, you will get the value as 0.7391. Like that, you have to calculate this calculation for all other alternatives. And for alternatives A3 to alternative A7, you will get these values. So out of these alternatives, the highest alternative is A3. The best value you will get in the case of alternative A3, that is 1.6257. So you can see in this case also, what we found that the best alternative is alternative 3. Okay, so most of the case we found alternative is 3. So you can make a conclusion that alternative 3 is the best. But it is always suggested to go for sensitivity analysis, to exchange the weight, and then see whether it is the model is robust or not. If there is no change, then definitely we are going to say that it is a robust model. Okay, so this is all about the 6D6 MCDM methods. For more details, you can follow the lecture by Professor Kumar Patel. You can go to YouTube and find Kumar Patel's video, and you can find details about these MCTM methods. Yeah, thank you everyone.